Hey guys, welcome to the next session on of rapid revision. This is the part 2 for enzymes. Part 1 we have just completed. This is a rapid revision session where we are discussing all the important topics in rapid succession. All right, marathon spree is going on tonight, 4 back-to-back sessions. Tomorrow also we have 2 back-to-back sessions. Yesterday we had 4 back-to-back sessions. Tomorrow we're going to have just 2 because tomorrow's New Year Eve, so you guys would want to relax, would want to party. So I'm just keeping sessions for tomorrow. Because that is why I'm covering maximum for tonight. Okay, let me know if I'm visible and audible to all of you. Let me just check if I'm visible and audible, and then we can start. Okay, I'm your educator for biochemistry on this platform as well as on Unacademy special classes. This is a new channel by Unacademy called Unacademy Future Doctors, specially dedicated to Prof 1 and Prof 2 students. Also very helpful for those of you preparing for NEET UG and NEET PG examination. Okay. Let us quickly discuss about the types of subscriptions for NEET PG that are available on Unacademy. These are of two types, Iconic as well as Plus. The Plus subscription comes with access to top educators across the country in the field of medicine through their live as well as recorded videos, live tests, special classes, um, and a lot of question banks of regularly updated questions, more than 25,000 questions, regularly updated with each and every entrance examination that comes by. And also you can access these notes in the printed PDF format after the class. Okay, so you don't have to bother about taking down the notes, you just have to bother about understanding while attending the class. Okay, the classes are in a simulated classroom environment with state-of-the-art tools like raise your hand feature and a lot. You can ask your doubts from the educator. Do attend a few special classes, and you will find them very interesting, and you will really motivated towards taking the subscription. Okay, and you can access these while on the go on any device of your choice. Okay, so that is a great benefit. And the Iconic subscription comes with additional features of resources from Prep Ladder as well. Okay, not forget to put in the educator code, that is DRSHUKLA, Dr. Shukla. It will fetch you a whopping 10% discount on the already subsidized price. Okay, so we have discussed about the definition of enzymes. We have discussed about the few important terminologies related to enzymes, about the rate, how the rate of enzyme is calculated. Now we shall be discussing about the classification of enzymes. Okay, all of you, who have followed me throughout this month would know about the classification of enzymes, the different categories of enzymes that are there, isn't it? Now let us quickly revise what are the different categories of enzymes. All right. Okay. The first one is what? Oxidoreductase. As the name suggests, what is an oxidoreductase? They perform oxidation reduction. These enzymes help in the oxidation reduction reaction, isn't it? Okay, they help in the oxidation reduction reactions. Now, what is an example? All the dehydrogenases, right? What is dehydrogenase? Because that will remove a hydrogen molecule, isn't it? Removing a hydrogen molecule. A very common example is what? NADH, dehydrogenase. Okay, lot of dehydrogenase reaction. What lot of dehydrogenase enzymes? Pyruvate dehydrogenase. Lot of dehydrogenase molecules there. Okay, they catalyze they are what? Oxidoreductases. This classification is very important. Okay, what are transferases? What is the function of transferase? As the name suggests, they will transfer something, isn't it? They will transfer one functional group to the other. A very common example is peptidyl transferase. What is unique about this enzyme, peptidyl transferase? Can any of you tell me? This is a ribozyme. We have discussed in the last class, isn't it? What ribozymes are? They are RNA molecules possessing enzymatic activity. Okay, so this peptidyl transferase is a type of transferase enzyme that forms peptide bonds between amino acids during the process of translation. Okay, you can go back to the process of translation, to the session on translation to understand this in great detail. We have discussed this 4 or 5 times. Alright, so peptidyl transferase is a type of ribozyme belonging to the category of transferases. The third one is what? Hydrolase. Now, what is a hydrolase? Hydro, something related to hydro. What is hydro? Something related to water. Okay, so this hydrolase, lase is breaking. So this causes hydrolytic cleavage. What is a hydrolytic cleavage? Cleavage by the addition of water. Okay, water will be added on the substrate molecule to cleave it. Okay, what is the example? Most of the digestive enzymes are hydrolases because the digestion occurs in a watery environment, isn't it? So most of the digestive enzymes are hydrolases. For example, lipase, amylase, all these enzymes, they are what? Hydrolases. Okay, phosphatase, they are hydrolases. Okay, next one is a similar enzyme group called lyase. Lyase is also something that breaks. Okay, but there is no addition of water, rather cleavage is by atom elimination. Cleavage is by atom elimination. Okay, got it? There's no addition of water, rather an atom or atoms are removed from the compound. So for example, carbonic anhydrase, extremely important example, carbonic anhydrase. Okay, next group is isomerase. A lot of enzymes, especially in glucose metabolism, you have read isomerase, right? There will be changes in the structural conformity will be changed. Okay, without changing the overall formula. Okay, like an isomer. Similarly, this isomerase enzyme will interchange the isomers, like phosphoglucoisomerase enzyme, phosphoglucoisomerase enzyme, which we lovingly call it just isomerase in glycolysis. This changes glucose 6-phosphate to fructose 6-phosphate. Okay, phosphoglucoisomerase. Now the sixth and the final category is that of ligases. Ligases, the chapter on DNA replication, we have read about DNA ligase. What happens is it joins two substrates and using what? It joins using what? ATP. Okay, hydrolysis of ATP occurs. That means it uses ATP molecules, the energy of the high energy phosphate in the ATP it uses to join two molecules. Okay, for example, DNA ligase joins the Okazaki fragments. Remember Okazaki fragments? Okazaki fragments, what are these? They are on the lagging, they form the lagging strand upon ligation. Okay, so the Okazaki fragments are formed by ligation of through DNA ligase enzyme. Okay, got it? Now we have understood the nomenclature, the different classification of the enzymes. Now what we are going to read about is, we are going to read about the mechanism of enzyme action. How the general, what happens is the enzymatic activity is denoted by the Fischer hypothesis. Fischer was a scientist who has worked a great deal on enzymes. Okay, Fischer hypothesis is the lock and key hypothesis. Okay, the lock and key model, saying that this is the enzyme. On this, the substrate fits like a lock and a key. This enzyme is like a lock and it has a stereo specificity. Okay, that is 3D specificity. 3D specificity it has, not just 2D, 3D specificity. Okay, so this substrate will fit on it. It will form an enzyme substrate complex. Okay, this enzyme substrate complex will be dissociated after an enzyme product complex, after this substrate has been modified to form the product. Okay, this enzyme and substrate will come together to form the enzyme substrate complex. After this forms the product, the enzyme will dissociate and go in its initial form, and the product will be released. Okay, got it? Got it, all of you? Now this site is the active site. This site on the enzyme where the substrate binds is the active site. It is usually a cleft. Suppose this enzyme is one single molecule. So it is usually a cleft in the monomeric or the single molecular enzymes. But if suppose this enzyme is formed by multiple molecules, so it will be a site in between the this active site will be a site in between these different molecules. Okay, it will be an interface in between these different multimeric molecules. Multimeric time. Got it? So this is the lock and key hypothesis of Fischer. Okay, now this enzyme substrate complex is where the catalysis takes place and product is formed. Okay, now this catalysis is of 4 types. The enzyme can perform catalysis in 4 different types. First one is by proximity. By bringing the substrates together, it can cause them to undergo catalysis. Okay, why? Because there is increased rate of bond formation because of increased proximity. Second is by acid-base catalysis. By acid-base catalysis. Okay, this is another when the functional groups of the substrates act as acids and bases and a reaction is performed. By strain, this is like an opposite of by proximity. While because of the strain on the functional group, because of the strain on the substrate, the bonds are broken. Okay, this is what is called Pauling's hypothesis. Pauling's hypothesis. Okay, all these we have discussed in great detail. Therefore, I'm not going in detail right now. I'm just telling you the terminologies for you to revise. Okay, how on which parts you have to focus. Then you can go back and revise through my classes. I've already taken these. Okay, and the fourth one, the most important one, is by covalent bond formation. What happens is, in this covalent bond formation, what happens is the enzyme and the substrate will form an intermediate. Okay, now this intermediate has a lower activation energy. Activation energy is the energy required for the reaction to start. There is a threshold of energy that has to be crossed. So this activation energy is that much energy that will help it in just crossing the threshold. So this intermediate has a lower threshold, lower activation energy. So it can very quickly, very efficiently and in an increased rapid manner move towards forming the product. Okay, and once the product is formed, the enzyme is eliminated, the enzyme is released in its initial unaltered form. So this intermediate is the temporary change in the conformity of the enzyme, but there is no permanent change here. Okay, and this covalent bond formation is called, this mechanism is called ping pong mechanism. Okay, just have a look at these and let me know if you're following. Okay, let me just check the comment section once to know if you guys are following. If there are any other questions that are following, I'll address them. Okay, just take a look for about 1 to 2 minutes and then tell me if there's anything that you want to be answered. Okay, otherwise we'll proceed further. Okay, all of you, is it clear with all of you? Now we shall read about a few of the terms about enzyme kinetics. Okay. Now can you guys tell me what are the factors affecting the rate of a reaction? The various factors affecting the rate of the reaction. Can you guys let me know? there are a lot of factors affecting the rate of a reaction, normal reaction, be it enzyme catalyzed or not. Okay, this is a general question. Temperature is one, right? With increased temperature, there is a lot of kinetic energy. Kinetic energy in the molecules increases, isn't it? And this kinetic energy is sufficient to overcome the activation energy. I told you activation energy is the minimum energy required for the molecules to cross over towards the product side. Okay, so temperature is one. It increases, the increased temperature increases the kinetic energy, the molecules, isn't it? So one is temperature. Following all of you, second is very important, the concentration of the reactants. Concentration of the reactants is another very important term. Okay, because increasing the concentration of the reactants will increase the collision between the molecules. Increasing the collision will increase the kinetic energy. Okay, so suppose if this is the reaction A plus B forming P. Okay, now if the concentration of A is doubled, what will happen? The rate of the reaction will double. If the concentration of both A and B is doubled, what will happen to the rate of the reaction? The rate of the reaction will what? The rate of the reaction will, see, suppose this is the concentration A, the concentration of B, and this is the concentration of the product. Okay, now the rate depends upon what? It depends upon the concentration of the substrates. Okay, it depends upon the concentration of the substrates. So if the rate of if the concentration of A is doubled, if the concentration of A is doubled, then what will happen is the rate of the reaction will be doubled. If the concentration of B is doubled, then the rate of the reaction will be doubled. If the concentration of both A and B is doubled, the rate of the reaction will be quadrupled, isn't it? Going by this, it will be quadrupled. Sorry, it is proportional to. Okay, got it? Alright, so it is what? It is the sum of the molar ratios of the reactants, just like probability. Okay, got it all of you following? This the rate of the reaction, how it depends upon the concentration of the reactants. Okay, got it? So by this proportionality sign, we can change this proportionality sign with an equal to sign by introducing a constant. Suppose this constant is K1. K1 is going in the forward direction. Okay, K1 this, and okay, what is K2? K2 is going in the backward direction. Since this is a reversible reaction, suppose this is a reversible reaction, at equilibrium, what will be there? The overall concentration of the reactants and products is constant. At equilibrium, the concentration is constant. Therefore, the rate of changing of the substrate to the products and the rate of changing of the products back to the reactants is same. Okay, is equal. Okay, so what is the other rate? This is the back rate. Okay, this is suppose the first rate, this is rate -1. -1 means the backward reaction. This is what? K -1. It will depend upon what? This is now the substrate for this, the backward reaction. Depend upon this. Okay, got it? Now what is K equilibrium? K equilibrium is the equilibrium constant. It is the ratio of the forward and the backward equilibrium constants. That means it is the ratio of this upon this. Got it? This is the equilibrium constant. Okay, it is the ratio of the equilibrium constants for the forward and the backward reactions. Ratio of the equilibrium constants. It is not the ratio of the rates. Equilibrium constant is the ratio of the rate constants. What is K1? It is the rate constant. It's called the rate constant of the forward reaction. What is K minus 1? It is the rate constant of the backward reaction. Okay. What is K EQ? It is the rate constant of, it is the equilibrium constant. Okay guys, following all of you, it is the equilibrium constant. So there was once an MCQ saying the equilibrium constant is the ratio of the rate of the forward reaction and the rate of the backward reaction. Is this true? Is this correct? No, we have discussed this. The equilibrium constant is not the constant of rates. It is not the ratio of rates. It is the ratio of rate constants. Okay, the equilibrium constant is the ratio of rate constants. All right. Following all of you? Okay. I hope you guys have understood this. Okay. Now what we'll see is, how we have seen how enzymes affect the reaction. Okay. Now what are the different factors affecting the enzyme catalyzed reaction? Okay, we'll see what are the different mechanisms which will affect the enzyme catalyzed reaction. First, temperature. Very, very important is the temperature. What will temperature do? Increase in the temperature will decrease the activation energy. Okay, so the activity of enzymes is increased, but only till a particular time, because after a particular temperature, what happens is the enzymes get denatured. They get denatured. So initially, for some time, the enzymatic activity increases only to experience a slope later on due to denaturation of enzymes. Because enzymes are what? Proteins. So extremely high temperatures will cause breakage in the covalent bonds. Okay. We saw how they have covalent bonds in the structure. So there will be breakage. Okay. So there is another one important term, that is Q10. Q10, that is temperature coefficient. What is the temperature coefficient? Temperature coefficient is the factor by which the rate of reaction increases with every 10 degree Celsius increase in temperature. Factor by which rate of reaction increases for every 10 degree Celsius increase in temperature. Okay. Now suppose Q10 for a reaction is 2. That means the reaction proceeds at twice the speed for every 10 degree Celsius increase in temperature. If you increase the temperature by 10 degree Celsius, the reaction will start proceeding at twice the normal speed. This is Q10 is equal to 2. This is the meaning of Q10. If it is equal to 3, that means it will proceed at thrice the speed. Okay, following all of you, let me check the comment section if there are any doubts. Next important factor that affects an enzyme catalyzed reaction is the pH. The pH, okay, or the hydrogen ion concentration. Log of the hydrogen ion concentration is what? pH. Logarithm of the enzyme hydrogen ion concentration is the pH. So the pH will also affect. Okay. Now what happens is, at optimal pH value, the enzymes will work optimally. Especially true for those enzymes that carry acid-base catalysis. We saw how 4 types of catalysis are there: by proximity, by strain, by acid-base catalysis, and by covalent bond formation. So especially for enzymes that carry out acid-base catalysis, for example, HIV protease enzyme, a classical example. For those enzymes, pH concentration of the solution is extremely important. Okay. Now third, the most important one is the substrate concentration. Okay, we saw how in a non-enzyme catalyzed reaction, substrate concentration increases the collision between molecules and increases the rate of the reaction. Now there is a peculiar trend in an enzyme catalyzed reaction. What is it? This curve is seen. Okay, this kind of a curve is seen, and what is this curve? This is the maximum velocity of the reaction. This increases, after that it becomes constant. Okay, the substrate, increasing the substrate concentration, this is the substrate concentration and this is the velocity of the reaction. Now increasing the substrate concentration will increase the speed of the reaction till a particular time, that is the V max, till a particular velocity, that is the V max. After this, the velocity becomes constant. Why? Because all the substrates, all the active sites of the enzymes have been saturated by the substrate. Okay. Now the substrate has increased so much that it has saturated all the active sites of the enzyme. Okay. So now the reaction is proceeding at its maximal capacity. Okay. Got it, guys? Understood? Understood. There is this term called V, half of V max. Okay, this is half of V max. Okay, now the substrate concentration at half of V max is called Km. The substrate concentration at half of V max is called Km. Okay, now this Km, the affinity of the enzyme for the substrate is inversely proportional to the Km. For a reaction, for a substrate, if the Km is very high, that means the enzyme has low affinity for that substrate. Okay, got it? Following all of you, do let me know. Okay, and this Km is the Michaelis-Menten constant. Okay, this is the Michaelis-Menten constant. All of you should know the full definition of Michaelis-Menten constant. What is Michaelis-Menten constant? What is this? This is the substrate concentration, isn't it? This is the substrate concentration. It is the substrate concentration at which the velocity of the reaction is half of the maximal velocity attainable at a particular concentration of the enzyme. Isn't it? Following? What is Michaelis-Menten constant? It is the substrate concentration. What substrate concentration? Substrate concentration at which the velocity of the reaction is half. V max half. It is half of the maximal velocity attainable at the particular enzyme concentration. If you increase the concentration of enzyme, there will be more active sites available now, so the velocity can increase further. Okay, so at a particular enzyme concentration, there will be only a few active sites. So those active sites, when they are saturated, the velocity will be maximum. Okay. Now, the half of that velocity is achieved at what substrate concentration? That substrate concentration is the Michaelis-Menten constant. Okay. And the affinity of the enzyme for the substrate is inversely proportional to this constant. Okay, guys. Got it? Following all of you, have you guys understood all of this? Now let us very quickly see different scenarios and how they affect the Km and how they affect the V max. Okay, there are three scenarios. First is when the substrate concentration is very, very less compared to the Km or the Michaelis-Menten constant. Km is also a substrate concentration only. Right? Km is also substrate concentration at which the velocity of the reaction is half of the maximal velocity for that particular concentration of enzyme. So when during the course of the reaction, when the substrate concentration is very less compared to Km, what will happen? What will happen right now? At this time, Km plus substrate, Km is the concentration of Michaelis-Menten constant. Km plus substrate is equal to what? It is equal to Km only. It is equal to Km only because S is very, very less. It is negligible compared to Km. Okay? Got it? So this is the initial velocity. This is the initial velocity or the rate of the reaction. It will depend upon the substrate concentration. Isn't it? It will depend upon the substrate concentration. Right? And how can you denote it? You will denote it as initial V initial, that is initial velocity, that is depending upon the concentration of the substrate. The initial velocity of the reaction when the substrate concentration is very less will depend upon the concentration of the substrate. So if you, it is directly proportional. So when you increase the substrate concentration, the reaction will proceed very fast. Okay, this happens initially because right now all the active sites have not been occupied. Okay, how will you denote it? Vi is equal to V max S. S is what? Concentration of substrate, isn't it? Isn't it, guys? Vi is equal to V max S upon Km plus S. Okay. Now this is equal to Km only. Now V max is also constant. Km is also constant. So Vi will depend upon S. So the initial velocity will be directly proportional to the concentration of the substrate when the substrate concentration is less as compared to Km. Okay, following all of you. How did we get this? How did we get this? From the rate of the reaction. Okay, the rate of the reaction. Now, suppose when the substrate concentration is very high compared to Km. Okay, Km is what? Km is also a substrate concentration only. When this substrate concentration, the current substrate concentration during the reaction is very high. There are three scenarios which we are discussing. So now what will happen? Km plus S will essentially mean S only because this is negligible. Okay. So how will you denote? Vi is the initial velocity is equal to V max into S upon Km plus S. So here this Km is equal to S only, right? So it will be V max S upon S only. Okay. So what will this be? This will be Vi is equal to V max. Now when the substrate concentration is very high, the velocity has reached the maximum velocity. Okay, the mathematical terminologies I am explaining verbally, okay, through normal language. So when the substrate concentration becomes very high, the initial velocity, the velocity of the reaction equals the V max. Now the third scenario is when substrate concentration is equal to Km. When substrate concentration is equal to Km, then Vi will be equal to V max S upon S plus S, you can say. Okay. So it will be what? V max S upon 2S. So Vi is equal to V max by 2, and this is what we discussed. When the substrate concentration is equal to Km, then the velocity of the reaction is half of the maximum velocity. Got it, guys? Got it, all of you? Following? Okay. Alright, so this was it for enzyme kinetics. I hope all of you understood. One Hill equation is also there. That Hill equation is for it is regarding the cooperative binding and dissociation, hemoglobin dissociation curve, oxyhemoglobin dissociation curve, which is sigmoidal. Okay, So all these things you have to revise again and again. These scenarios you should know how to calculate Michaelis-Menten constant. You should know this reaction Vi is equal to Vmax into substrate concentration upon Km plus substrate concentration. This you should know. All these things you should understand. Very, very important. All the factors in which enzyme catalyzed reaction depends. All these things are extremely, extremely important. Okay, now let me just check if you have some doubts and then we can proceed with the next session. Okay. All right. So there are no doubts as such. Now let us conclude this. If you guys like this session, then do subscribe to this channel. This is Unacademy Future Doctors. Stay tuned for regular updates and such rapid revision sessions as well. Okay, we will meet now after a few minutes for another session on thyroid hormones and another session on glycogen. Okay, after that, tonight at 10:45 p.m. we have another MCQ session on Unacademy app called MBBS MCQ Bonus Biochemistry Sessions. It is the 7th in the series, guys. So please do join tonight. You'll have a lot of fun answering the MCQs. Okay. Okay then. Thank you. Bye bye. See you in a few minutes.